All right, guys, I apologize that I didn't finish the lecture today. I think it was two things. We went over the test, and then I dove so much into that Calc 1 stuff, kind of on purpose to just sort of overwhelm you, go like, man, you learned a lot. Or you didn't learn a lot, because I know that Chapter 1 test is brutal for all of you guys. And then just the experience of the coffee shop. Did we meet? Is there a coffee shop? Did it get blown up? I just kind of wanted to just splatter you with stuff and then go, hey, there's another way to do it. Um, so up front, apologize again that I did not finish the video lecture. So here it is now for you. All right, so I'm just going to do more practice problems, and I think that will help you if you need the help. So number 14, first thing, always first thing, plug in, and you get 0 over 0. I give you a check saying that's indeterminate because I don't know what 0 over 0 equals. So I'm allowed to take derivatives of top and bottom. So I'm going to do negative 2x over 2 square roots 25 minus x squared all over 1. Okay. So in that, if I just kind of clean it up a little bit, I'm just going to look at negative x over 2 square roots. No, sorry, not 2. Negative x over the square root of 25 minus x squared. And when I plug into that, I get negative 5 over 0. Now notice that's not indeterminate. It's not 0 over 0. So I can't just keep going. Do not take more derivatives. You can't do that. You got to stop. Now ask yourself here. Negative 5 over basically something really, really, really small gets me negative infinity. Okay. All right, let's look at a couple more of these. Now, we've done these, especially the black one. We've done the black one before back in Calc 1. And that's where you're trying to go like, man, I wish this was a 4 there. And then I could say that goes to 1. So how can I change that 5 to a 4? That's what you used to do in Calc 1. And the answer was 4/5. So let's do it now in the Calc 2 style. Plug in 0, I get 0 over 0, indeterminate. So I can take the derivatives of top and bottom separately. I get 4 cosine 4x all over 5. Plug in 0, and I get 4/5. Okay, let's try this one out. I get 0 over 0, can't do. So now I'm going to try and take derivatives of top and bottom. I get 3 cosine 3x over 5 secant squared 5x. Now I'm going to plug in. I get a 3 on top. If cosine of 0 is 0, if cosine of 0 is 1, then secant of 0 is also 1. So I get that. Call it a day. Again, these go pretty quick because a couple things. You can just take derivatives until it works out. And these derivatives are not quotient rules. You're just doing a derivative of the top guy over the derivative of the bottom guy. Here's one where it's infinity over infinity is going to be the indeterminate form. Plug in infinity, I get infinity over infinity. Can't do. We've talked about this one today. So this in Calc 1, what I told you guys, again, I want to make sure you see the relationship. Degrees are equal, so I'm dividing the leading coefficients, and 6 divided by 3 is 2. Let me show you that by hand. So this is limit x goes to infinity of 12x minus 5 over 6x plus 1,000. Plug in infinity, I get infinity over infinity, which means I can do it again. So I go limit x goes to infinity, and I get 12 over 6, which equals 2, and I stop. Okay. Next one. Okay. Now, all of these Hopital rules have been working if it's a fraction over a fraction, and you get 0 over 0 or infinity over infinity. This problem here, there's no fraction. Okay. So when I plug in the negative infinity, I get negative infinity times, let's see, e to the negative infinity. Now, let's just visually think about this. Here's e to the x. And if I'm plugging in negative infinity, that means I'm going way over here and trying to grab something over there. That's a 0. So negative infinity times a 0, that's an indeterminate form. I want to say it's 0 because I want to say anything times 0 equals 0, but anything means any number. Right now, negative infinity is an idea, so it's indeterminate. So I need to take derivatives of top and bottom, but I don't have a top and I don't have a bottom. So I'm going to try to force a fraction. And when I force that fraction, I'm going to pull that guy down, or I'm going to pull this guy down. You have a choice between which guy you're going to pull down. So let's try this. Limit x goes to negative infinity. Let's keep this guy up, and let's pull that guy down. Okay. Now, let's see what we can get. So when I look at this, I'm going to plug in, and I get negative infinity. Now, e to the negative actually means e to the positive infinity, which blows up. That's indeterminate, so I can go on. Now I have a top and a bottom, so I can take the derivative. Let's see, 3x squared negative e to the negative x. Plug in again. This time I get a positive infinity over a negative infinity, which is still indeterminate. So I can go again. Limit x goes to negative infinity of 6x over e to the negative x. That's a negative infinity over infinity. That's still not good. I think you're seeing the pattern though. One guy never changes, but the top guy does change. So now I get a 6 over negative e to the negative x. And that gets me 6 over a big negative number. So 6 over a really, really, really big number gets me 0. So it took a couple steps because I went with that x cubed, and I had to get him to 3x squared to 6x to 6. But in the end, I was able to pull down and get the 0, which basically means who's more powerful, the x guy or the e guy? Who is more powerful? That is a question I want to add right here. Who is more powerful? X to the n or e to the x? What I mean by more powerful is, another way to phrase it is, who um who grows quicker out at x goes to infinity. Okay, so visually, there's e to the x. Here's x. Here's x squared. Here x cubed. Right now, who seems to be growing quicker? The x squareds or the x cubes? And that e to x seems to be slow. But you remember, this right now is all at the place of 5, let's say. Meaning, what's bigger, 5 cubed or e to the 5? All right, so 5 cubed or e to the 5th. 5 cubed is 125. E to the 5th, that's like 2.8 to the 5th, which is probably, without a calculator, like, I don't know, 2.8 to the 5th, 2.8 to the 5th. Calculator. I'm finding one, students. Don't worry, I have a calculator because I'm math boy. I'm a superhero. I'm going to save your day. That's 172. So right there, who's winning? E to the 5th. But let's say I did something like maybe at 4 or 2 cubed or e to the 2. So this is asking kind of back here, who's the winner? 2 cubed is 8 and e squared is 7 point whatever. So 8 versus 7.38. So do you notice here on this cubed part, the cube guy here is winning at 2, but then later at 5, the E guy is winning. So on the cube stuff, who's more powerful? It looks like the E guy, because in the end, he's going to go quicker. He's blowing up quicker. But if I wanted to, I could reset this, and I might ask you, okay, well, who's quicker than here? X to the 10th or E to the X? And if you want, you could check at, let's say, X equals 2. Who's more powerful? 2 to the 10th or E to the 2? Definitely that guy. But if I check at X is 10, I'd have to go, who's more powerful? 10 to the 10 or E to the 10? And let's think about that. 10 raised 10 times or 2.8 raised 10 times? Still this guy. But what about X equals 100? Now we might have a debate. 110 times or E 100 times? I bet that guy wins. So I'm curious though, if you notice, I'm not asking you for X to the 10th or X to the 3rd or X to the 4th. I'm asking you for X to the N. Who is bigger or more powerful? Who grows quicker? X to the N or E to the X? Here's how you can tell. Limit as X goes to infinity of X to the N over E to the X. Okay. If fraction equals 0, bottom wins, E to X more powerful. If fraction equals infinity plus or minus, then we've learned that top wins, and this guy is more powerful. And there's one more option here. If fraction equals a number, then top and bottom are equal. Think like in degrees when we've done the x squared over x squared. So same powers. Okay. So the question would be, what does this thing equal? Who wins? That's the debate. Who wins? Top, bottom, or it's a balance? Top, bottom, or it's a balance? Well, if you look at this problem, let's look at this. Limit x goes to infinity of x to the n over e to the x. If you plug in, you get that. So you can Hopital. So if I Hopital, bottom stays e to the x, meaning the bottom is always going to be over infinity. Look what happens. This derivative would be n, bring the exponent down, x to the n minus 1. And that most likely is probably still infinity. Now you might go, whoa, what's going on here? Well, the next guy would be n minus 1, x to the n minus 2, again, over e to the x. And that's probably still infinity over infinity. But can you do this all the way down to where you get to a point where it's going to be limit x goes to infinity of e to the x, and there's going to be a number on top. And then that would be a number divided by infinity, which goes to 0. So e to the x more powerful. Why I know it's going to go down to a 0, just look at a sequence like this. I had x to the 5th. It'd go to 5x to the 4th, 20x cubed, 60x squared, 120x, 120. Do you agree that I can tear down a toy train all the way down to a number where e to the x just stays e to the x? So I tear down the top, the bottom stays the same. The bottom is bigger, more powerful. That's why it drags that fraction to 0. Okay. All right, let's look at this indeterminate form again. If you plug in 0 here, you get 0 times infinity. If you're curious on that infinity part, let me tell you that cotangent of x equals cosine of x over sine of x. And if you plug in really close to 0, you're getting a 1 over something really small and positive, which goes to infinity. Okay? So I need a force of fraction. Force fraction. I get limit x goes to 0 from the right side of x cubed over, and I just need to pull down that cotangent. But when you pull that down, I think I can make it tangent x. And I'm going to try. Let's see here. Plug in, I get 0 over, let's see, tangent is 0, indeterminate. So I can go again. 3x squared over secant squared x. Okay, plug in 0 now. I get 0 over 1, which is 0. So, oh, wait. Secant squared. Yeah. Yep, cool. So I get that guy to be 0. Now, there's your homework. So hopefully this last 16 minutes, I just basically gave you more examples and just showed you how you can keep taking the derivative over and over and over until you get to something that's not indeterminate, and then you can get an answer. Tomorrow I'm gone. I kind of forgot to tell you guys that. I have a huge meeting down at District tomorrow about that student engagement stuff. There are videos up online. There's 3 videos. They will last about 50 minutes total. Then you'll have plenty of time in class to actually get some of the homework done and talk through problems with your partners and groups. Then over the 3-day long weekend, I would like you to watch one extra video. It's a preview of what we're doing next week. All of that's online. The sub will tell you that as well. But hopefully all this stuff helps you and you have a great life. Bye.